Yeah, good morning, everyone. Welcome to this session. As most of you know, I am Nidhi Singh. I am working as a QA engineer at SITA.dev, and today I am taking the session on SDLC and its model. So let's start. Thank you for joining me today. I'm excited to present a very important topic for anyone involved in software development. And the topic is, as you all know, software development life cycle and its models. In short form, it is called SDLC and its model. Yeah. So here we'll explore how the software is planned, built, created, tested, and managed from beginning to the end. So whether you are a student or the developer or QA analyst like me or a project manager, this session will be very helpful for you in understanding the SDLC and its model to know how the software work more effectively and deliver the better results. So let's get started. SDLC. As you all know, SDLC stands for Software Development Lifecycle. So what exactly this SDLC is? The software development lifecycle is the structured process and which guide us how the software is created from start to the finish, how we are building the software from the starting and how we are getting the finished product. This all we are learning in SDLC. So SDLC is the structured process that has the defined phases like design, development, testing, deployment, and maintenance. So now the question comes, why we should learn this SDLC? What is the purpose of learning this SDLC, and how it is going to help us in future? So here it is the answer. It is a structured process that helps us to know what is the workflow. It helps us to know how to organize the workflow so that everyone in the team should understand what to do, how to do, and what is going in this software. So this is the structured process, and all this knowledge comes through SDLC only. It minimizes the risk and helps in boosting the success of the project. It minimizes the risk of unplanned occurrences, and the if the requirements are not clear, all this we can sort it out through the SDLC. Each stage of the SDLC helps to check and ensure the final product what we are building is correct and it is according to the user expectation. With the better planning and a fewer surprises, SDLC helps keep the project within budget and our time. It optimizes the resources for timely and the within the budget delivery. So this is why we are studying the SDLC. Next is the phases of the SDLC. So SDLC has the specific defined phases. So let's take a closer look on the phases of the SDLC. SDLC has 7 major phases: planning, analysis, design, development, implementation, testing, deployment, and maintenance. So these are the 7 phases of the SDLC. First, we starts with the planning. It is also called requirement gathering phase. In this phase, project plan is created, outlined, and all these are planned, like how much resources are needed, what is the budget of this project, and what is going to happen in the project. All this is planned in the planning phase. Basically, planning is done in this phase, and it is also called requirement gathering phase. Now we have the planning. We have the plan document in our hand. Now next phase is analysis phase. Now on all the requirement, analysis is done. Project team gathers and analyze the requirement from the stakeholder. This is the very important phase because misunderstandings here can lead to problems later. So these two phases are the very important phase. Everything should be planned and requirement should be gathered properly. Next is the design phase. Now we have planned the software. Now we have the analyze what is done. Everything is in our hand. Now the designs of the software is done. So here architectural and technical design of the software is created in this phase. So based on the requirement that we have gathered in the above two phase, architecture is planned. This include like UI designs, database design, technical specification, everything related to design is done here. Next phase is developing phase. It is also called implementation phase. It is also called coding phase. So this is the phase where actually coding of the programming takes place. Developer starts writing the code. This is often the most in time taking part of the process. So here every coding is done. Basically, the software is building in this phase only. Next come the testing phase. So before the software is released, it undergoes rigorous testing. Thoroughly testing is done before it is released to the end employees and user. So software undergoes various testing phases. In this phase, like functional testing, non-functional testing, all aspects of testing is done in this phase to make sure everything is working as intended. Next is the deployment phase. Now everything is done, designing done, testing is done. Next is the development deployment phase. In this phase, software is deployed to the production environment. Now software is released to the users and everything is ready. Now it's time to handle the software to the end user. So in this phase, this part is done. So here from 1 to 6, now software is we make the software and deployed it to end user. Now what last come? It is the maintenance phase. It's not like that if we deploy the software to the end user and our work is finished. No, software need maintenance also. If we need to add more features, and if there is any bug, all these fixes, all this done, all these issues will be done under the maintenance phase to ensure that software continues to function correctly, efficiently, and securely. It's not like that if it is deployed, then our work is finished. No, maintenance phase is also a very important phase of the software development lifecycle. So each three phases has a unique role, and skipping any of the phase can lead to delay, over cost overruns, and poor quality of the software. So we should follow all these phases, and it is very important. Next is the software development models, that is waterfall model. So now it's time to deep dive into the SDLC models, and we'll start with the waterfall model. This is the very basic model of the SDLC. So waterfall model is one of the earliest SDLC model that follows a linear sequential phase. So each phase in this model, each phase must be completed before the next phase is started. So these are the phases of the waterfall model. I'll explain in the next slide. So I just want to tell you that waterfall model is like suppose a waterfall, like in the waterfall, water is flowing. It's flowing from up to down. This is what happening in this model. So these are the phases of this model: requirement gathering, system design, implementation, testing, deployment, and maintenance. So system design will be done only when requirement gathering phase is completed. Implementation process will be done only when system design is completed. Similarly, testing is done when implementation is completed. So each next phases depends on the previous phase. This is the waterfall model. We cannot do maintenance unless and until deployment is done. So this is the phase. This is the waterfall model. It is very old model, and because it is linear, that's why it is called sequential model also. So what are the advantages and disadvantages of waterfall model? We'll see. It is easy to understand and use because all the phases are very clear, and one phase is dependent on the previous phase. So it's very easy and simple and linear model. Whereas if we see the disadvantages, it is costly because suppose if we are in third stage and the customer wants, no, I want this also to be added in the previous stage, then it is very difficult. So that's why it is costly. Once the requirement is fixed, it is fixed. It's very uh, costly to add any missing requirement in this waterfall model. So this is suitable for the project that has stable and suitable requirement definition. It does not accept the requirement that keeps on changing. It is suitable for the project with properly understood technology, because everything is fixed and we cannot change. Changes cannot be entertained in this model. It is not suitable for the development method for ongoing project. So the phases do not overlap, as I told you. It is not flexible. There is high risk associated with this model. It is suitable for small project only, and it does not support prototyping issue. Prototype I will explain in the next model. So this is about waterfall model, and nowadays, like, it's very less than that we are using waterfall model, and it is very old and traditional model that we are using in earlier time. Most of the company, only agile model is followed. Coming to next. Yeah. Next is the verification and validation model. It is also called V2 model, or it is also known as V model. So this is the extension of the waterfall model, but with the focus on the testing and the development stage. Here, it is similar to a waterfall model only, but only thing is, in this, testing phase is incorporated at very beginning. So testing and development phases are going parallel in this model. So this is verification model, and the shape of this model is V shape to show you the relationship between the testing and the development model. This is the V model. So this is the verification phase, and this is the validation phase. This side, the left side, shows the development side, and the right side shows the testing side. So now I told you, in SDLC, the project starts with the requirement gathering. So when the requirement gathering in the development stage only, requirement gathering phase is done, side by side, acceptance designs are created, and for that UAT is done. On the testing side, UAT is done. So here, in the first phase only, the testing part is incorporated. Similarly, after requirement gathering, when functional testing is done, then functional design is created, and it is functional testing is done on the right side. Then high level design and low level designs are created. For those design, integration testing and unit testing are done in the parallel. Parallelly, the development is going on, side by side, testing is also going on. And for it is like extension of waterfall model only. So this is verification. Verification basically tell us how we are going to build the software. And validation is like, we are validating the software. What product we have built is right or not, whether we are building right product or not. This is verification and the validation. So this SDLC model is great for the critical software, like aerospace, and where the testing is required from the initial stage only. So in those software, this V model is followed, and where quality is non-negotiable. So we cannot negotiate with the quality of the software. So in those kind of software, the testing is, we have to start this testing from the initial level. So for those software, this V model is followed. So let's deep dive in the advantages and the disadvantages of the V model. Advantages are, it emphasizes the testing early and consistently. It is very simple and easy to understand because it is based on the waterfall model only, and it has clear deliverable for each phase. For each phase, we have clear deliverable against which the testing is done. And disadvantages are, it is time taking, not suitable for agile and evolving requirement, because changing, it is very difficult to incorporate the changes in the middle of this SDLC. So that's why it is rigid and not flexible for the changes. So if there is any fixing issue, then we have to bear the high cost. So these are the disadvantages of the V model. Next is the spiral model. So let's take a look on the spiral model. Spiral model is developed by Barry Boehm in 1986. As it is a software development process combining iterative development and risk management. Iterative development means changing and repeated development in repeated cycles. This is called iterative development. Iterative words mean repeated. So when we are combining the risk analysis and iterative development together, the fundamentals of the spiral model initiates. It emphasizes the risk analysis and refinement through repeated cycle. So spiral model has 4 phases: planning, risk analysis, engineering, and evaluate. So planning phase defines the clear objectives, alternative, and constraints. So what we have to do, all this is planned in the planning phase only. After planning, risk analysis is done, identifying the assess and reduce the risk. Like we have to analyze how to mitigate the risk if there is any risk. So we have to find the solution to mitigate those risks. Then the product is designed, developed, and the testing is done. So all this is done in the engineering phase, and then evaluation is done. The software is released for customer reviews and feedback in order to change, in order to get better. So these phases repeat again and again. So this is called iterative because these are repeating again and again. Planning, risk analysis, engineering, and evaluation. Again, planning, risk analysis, engineering, and evaluation. So at the end, a small working software is delivered, that is called prototype. Prototype is the dummy software. It is not exact software. It is a dummy software that is released in order to understand what are the customer feedback and was is this is the thing what is the customer is actually wanting. So that prototype is developed. After gaining the feedback from the customer, the changes are done in the prototype in order to uh, uh, increase the quality of the product. So this process goes spirally. So this is called spiral model only, and it is a combination of risk analysis and the iterative development. Yeah, now comes with pros and cons of the spiral model. So advantages are it really because every step we are doing risk analysis. So it reduces the risk because so many risk mechanisms are in place. So risk reduction mechanisms are placed in this spiral model. It supports iteration and reflects real world practice, and it is very systematic approach. Disadvantages are it requires expertise. Only the person who has specific expertise in risk evaluation and reduction of the risk can work in this project. It is very complex and it is very slow also. So and it is difficult to follow all the phases strictly. So this is the main disadvantage of this model because it is time taking and it is applicable for large systems only. So this is the advantages and disadvantages of the spiral model. And this model is using internally where there are large system and where there are like there are certain software where we cannot take risk of any flaw. So in those system, this spiral model is used to be very sure and to make sure that software what we are building is 100% bug free. But it is very unlikely to say like software is 100% bug free because errors are always there. But to reduce the risk of error, so this software is this SDLC method is followed. uh, Spiral method has risk analysis. So it is mainly important followed for the large system only. Next comes the agile model. This is the yeah. Next comes the agile model. This is the most commonly used model across the world. Nowadays, companies are following agile method only. It is a method where iterative delivery take place. So the software is delivered in the short sprint. Sprints are the a fixed time. It's a like fixed time. It's usually a sprints last for 2 to 4 weeks. So in that week only, a small part of the software is released. So and again on that part of software, the functions are built. So these sprints repeat again and again, and so no, so that we'll get a complete working software. This is the agile model. It is very good model. Nowadays it is very popular. It involves continuous feedback from the customer. Customer is welcome. Like customer can give the change in the requirement at any part of this SDLC, and changes are welcomed. So continuous feedback from the customer is required for this method, and customer is in continuous touch. So he knows what is going in, and now at what period of time what work is going on. This team is working on which part, the other team is working on which part. Everything customer knows, so he has that confidence, like something is going on the project. So this is the agile model. So it flexibly handles the changing requirement. That's why it is more popular nowadays. And the popular frameworks for agile are Scrum, Kanban, XP, and Lean. So next is, what are the key principles of agile? What makes it more popular nowadays? So here, individual and interaction over the like individual and interaction are focused over the processes and tools. So we, as I told you, like customer is in continuous touch. So it's not like that we are working theoretically or practically, that's it. No, and customer has given the requirement, and only at the end when we are delivering the software, then only he knows, okay, this is the product that is made. No, it's not like that in agile. In agile, customer knows everything, client knows everything what is going. Now is this part of the time, like today in this sprint, this work is going to do and I will get this thing. So he has also the satisfaction. So that's why individual interactions are more focused over the processes and tools. Working software over the comprehensive documentation. Here, documentation is not preferred. It's not like that we are focusing only on documentation. Rather than documentation, we are focusing on the working software only. Small chunks of software is delivered after the each sprint. Next is customer collaboration over contract negotiation. And third is responding to change over the following a plan. It's not like that, what like in the requirement gathering phase you have fixed something and that is concrete. No, this is not acceptable in agile. In agile, the changes are welcomed at any part of the phase. So you are in deployment phase and end of the deployment. Now the customer says, now I want this feature to be added. So you cannot say no. The changes you have to incorporate it. So that's why this is the flexibility of the agile that we have, that this model is giving. So we are working in small chunk of time, that is called sprint. So this is the fundamentals and the key principles of the agile. So here it's showing the sprint, like for sprint 0. First we do the project planning, then we are like deciding, okay, with this particular, it's not like that for whole project we can do in particular sprint. Like in sprint usually lasts for 2 to 4 weeks. You cannot end the project, finish the project in 4 weeks. So we are fixing what is important and what we need to do earlier, so that we are doing it. We are creating the product backlog for that. For now the sprint is started, we'll plan for everything. Where like after 4 weeks, after 2 weeks, suppose we have fixed our sprint will be of 2 weeks. So we plan like after 2 weeks we are going to work on this, our team will work on this, and after 2 weeks we are showing these things to the customer. So this is the thing. Now then the sprint is started, and sprint is executed, then sprint is at the end, the sprint is reviewed by the product owner, and then retrospective is also done. Retrospective means we'll work, okay, in this sprint, this went well, this doesn't went well, and what was not well, we how we can improve it. So this thing is called sprint retrospective. So this is the way of working in agile, and because here retrospective is also we are doing, that's why every time when we are going through sprint 0, sprint 1, sprint 2, we are getting more better and better. So that's why agile is more popular nowadays. So these are the popular framework that agile we are using in agile. Framework are nothing like it's a way of method, way how we are doing and exhibiting the agile. So these are Scrum, Kanban, Extreme Programming, and Lean. Scrum is like most of the company are using Scrum. Here we have different roles like product owner and sprints are started, and all this comes in sprint Scrum. In Kanban, there is a different visual board, like you fix your work. Okay, I'm going to work on these things. So you have to move your work. Okay, these are to do thing, these are in progress thing, and these are done things. So this is a visual representation, different visual representation only in Kanban. In extreme programming, it is usually used in engineering, where we have to show like this is in engineering related work we are doing in XP, and Lean is for manufacturing things. So this is about Lean. Next is iterative model. Iterative model develop the software through repeated cycle only. Here also we are developing the software through repetitive cycles. Each iteration include planning, design, development, testing. So these are the phases of the iteration model. So once one cycle is done, then again second cycle is created. Then second cycle is done, then third cycle is created. Iteration when repeating. So this is the iterative model. So product evolve through successive refinement. When the product, I made this product, okay, oh, this is not good in this product. Now in second repetition, I'll take the customer feedback and I'll add that thing that is missing in the second iteration. Similarly, then again the product is sent to the customer feedback. Based on the feedback, again the changes are done in the third iteration. So this is iterative model. Feedback is gathered and used to improve the future iteration. So in this way, in small chunks, the iteration development and model is going. Phases of iteration models are simple: planning, requirement analysis, design, building, and testing. So this in this phase, suppose I made a software, then it will go for customer feedback. Again, customer say, no, I want this thing in the project to be included. I want, suppose you have added only Paytm or PayPal in this. I want different thing, different credit card option in the payment option. So that I will go through, and then again the same phases are done: design, planning, design, building, testing. So again these things are done, and that feature is added. Now it will again go with to the customer for the review. Based on the feedback, the iteration is done in the third iteration. Similarly, when n number of iteration is done, unless and until we are not getting the required product according to the user requirement. Next is I told you like so many models: iteration, iterative model, agile model, waterfall model, spiral model. How to choose which is the right SDLC model? There are so many models in the market. We have to make the decision which is the right model. So all these thing depends on many factors like project size, client involvement, risk factors, requirement stability, deadlines, and team experience. Project size means for small size project, we cannot use spiral model. As I told you, it is used for large projects only, because it is very costly. If we are using it for the small project, it's simply waste of money only. So based on the project size, we can decide. For if the project size is small, we can go for waterfall model. So this client involvement, if there is a client involvement at every step of the software, so we'll opt for agile model, because agile welcome the changes at any point of the development. Risk factor, if more risk is included in the process, and so we will opt for the spiral model, because in that model risk analysis is involved. That requirement stability, if requirement are stable, like once it is fixed, it is fixed, we will go with waterfall model. And if it is not there, then we cannot go with waterfall model. Similarly, deadlines, if like we need the project earlier, so we'll go for agile model. If like it is like deadline is not near, then we can go opt for the other models also. Team experience, uh, like spiral model, we cannot uh, uh, take any team member that is not experienced, because that in spiral model risk analysis is involved, and that wants the speciality, that should be specialized person who can conduct the spiral model only. So if team is not much experienced, we can opt for waterfall model, iterative model, or agile model. If it highly risk is involved and speciality is required, and so we can go for the spiral model. So based on these all factors, we can choose what kind of right model will be suitable for a particular software. Yeah. So this was about the software development life cycle and its phases. Thank you everyone for listening. And it's time for Q&A. Yeah, the stage is all yours. You can ask anything.
Hey, hi Nidhi.
Hi, Prajakta.
Could you please explain the verification and validation difference once again?
Yeah, sure. Verification means we have to, uh, in simple words, I can say verification means how we are building the software. This is the verification, like what we have, what this process oriented, like what steps we are following for building the product. So it is
Okay.
process oriented is verification, and validation is product oriented. We are checking the software that we have built is right or not, whether we have built right product or not. This is validation. We are validating that, like now software is built, software is in our hand, we have to check it is meeting the user requirement or not. This is validation. This is a major difference between verification and validation. Verification is process oriented, and the validation is product oriented.
Okay. So it means like before our end product is developed, the verification is takes place, and
Yes,
after it, the validation will be takes
yes,
place.
yes.
Yeah. Yeah.
Yeah.
Okay.
Yeah.
Thanks.
Anything else like?
One small doubt, like maybe we are going to conduct one boot camp from the 9th for Jira tools and all. So
Yes,
there we are going to work on agile methodologies only, right?
yes, that
So
is the
there we
agile
will
method.
learn about the sprint, this all the things which you have explained in the agile model now,
Yeah,
that all the things in practical we will work on.
yeah, we'll follow the agile ways in that boot camp.
Mhm. Okay. So nowadays, is there any company who follows the spiral model?
For very less, like because it is for the critical project like aerospace projects, and
Okay.
uh, like not astronaut, like space related project where we
Mm.
cannot take the risk. So for that product softwares only we are following the spiral phase, because it is expensive. for small software, suppose I'm building one e-commerce application, I cannot follow spiral model for that because it is expensive, and on top of that
Mm.
experience is required, and it will
Mm.
cost a lot to the company. So, and if there is like 10 10 to 20% fault in the software, I can
Mm.
take the risk because it will, retesting is done and I'll make sure that software is bug free. But for the aerospace related project, for some of the critical health related project softwares, we cannot take the
Mm.
risk. And for that large complex software, the spiral SDLC form is followed.
Mhm. Okay. And in the interview, what kind of question is asked on this SDLC models? Do they ask any particular model or
Like,
specific agile?
according to my understanding, mostly question are asked from the agile model only, because nowadays worldwide company are following the agile methods only, and the
Mm-hmm.
phases of from the SDLC phases, the questions comes like in what phase what we are doing. So
Okay.
agile and spiral, like spiral also. Uh, First, if I take the rank, first is the agile model, then is the verification validation, because it's confusing what is verification and what is validation,
Yeah.
and then that's validation, and then this spiral, this come.
Okay. Yeah. Pretty good. Thank you.
Anything else? Like Kamla,
It was nice presentation, Nidhi. Had a
correct.
clear idea, like you explained all the models. Yeah, had a good clear idea about it.
Thank you so much. Anything that is not clear, you can ask. Like I'll explain.
Yeah, sure.
Okay, then I'll stop the recording.
It was great session, Nidhi.
Thank you, Pooja.
It was very nice, very informative, Nidhi.
Thank you, Shaleshri. I think I can see some questions in the chat. I think Prajakta, all your queries are answered, if I'm not wrong.
Yeah. Yeah.
Yeah,
True.
yeah. Okay, then let's stop the recording. Yeah. Thank you so much for joining, everyone. We'll meet in the next session. Bye bye.
Thank
Bye.
you. Bye bye.
Thank you. Bye.